Okay, guys. Today's lesson for NTI Day 26 is titled Secant Lines. So we're going to be looking at all kinds of different, well, we're going to be focusing on one, but the focus today is on angles formed by secant lines. So let's just jump into the notes. We've defined them a million times before. We're going to define them 1,000,001 after today. So the first definition on your notes is tangent line. And a tangent line is a line that intersects a circle at exactly one point. So if you got a circle and a line going through, it's going to touch the edge of that circle at just one point. We should be comfortable with both of these terms. And then a secant line is a line intersecting a circle at 2 points, right? So the example I keep talking about is whenever you're playing a battle royale, where are we dropping, boys? Well, you have the storm circle, and then you have the trajectory that the battle bus is taking you. And that usually forms a secant line, meaning there's the storm circle, and there's the path of the battle bus. Well, the path of the battle bus just formed a secant line with that circle because it intersected the circle at 2 points, whereas a tangent line is just grazes the circle at 1 point. You can see the difference. Okay, I don't have it written down here, but if you look on your notes, you see circles with secant lines can be represented in 4 different ways, and you have those 4 circles, 1, 2, 3, 4, and each have different configurations of secant lines. So circle 1, that's what we're going to be focusing on today. So you need to be looking at your notes as you have the video pulled up. I didn't print these out because our printer's out of ink and we don't want to go out and, we don't want to be out in public and just to get ink. So that's why I'm writing it down on the paper like this. So there's nothing for you to fill in on the notes for circle 1. Number 2 says circle 2 shows an blank angle. Well, circle 2 shows an inscribed angle because the vertex is just a number 2. You have a circle that looks like this. Just like that. So you have an inscribed angle. Okay, the measurement of the intersection of the 2 secant lines, so you have the 2 secant lines, the measure of this intersection, so this angle where the 2 secant lines meet is half the measurement of the arc. We've been doing this for a couple weeks now. We know that the central angle equals this arc. We know that the inscribed angle is half of that arc. Okay, number 3 is circle 3. We haven't discussed yet, but we will. And then circle 4 shows 2 secant lines that are parallel. We learned previously that arcs in between 2 parallel secants are congruent. And just to scribble just real quick what that looks like is you have these 2 parallel lines. So these are parallel. And the arcs in between the parallel lines are congruent, meaning they're the exact same. Okay, let's take a look at a couple of examples to see how we solve for unknown angles, like how we have in circle 1. And again, you have to be looking on your notes to know what circle 1 looks like. So let's look at example 1A here. We have the circle, and then we have these 2 secant lines. G, you can tell, this is not the center of the circle. The center of the circle will be somewhere closer to here. So G is just the point where they intersect. You have a few bits of information. So we're trying to solve for this angle X degrees right here. This is what we're trying to solve for ultimately. Arc BE is 120 degrees, and then arc DC is 40 degrees. That's all we have to work with. How are we going to solve for angle X? here's how this is going to work, guys. So for example 1A and then example 1B that I'll probably do in a separate video, or I guess we could maybe squeeze it on here, we'll see. But example 1A and 1B, we're going to solve it I'm going to prove how to solve for these, but then at the end I'm going to give you a shortcut. So I'm going to solve for 1A, 1B. You need to follow along, you need to fill in your notes, but I'm going to give you a shortcut after, and it's going to make it a lot easier. But I'm going to show you where it comes from first. So let's draw an imaginary, so here's point B and here's point D. We can draw an imaginary line connecting B and D. It wasn't part of the problem, but we're going to sketch it. And you could also do the same thing for E to C, but you only really need to do it for one of them. So we're going to go from B to D. B is the endpoint of one secant line, or I guess this is technically a chord. And then D is the endpoint of another chord. So we're going to connect these two chords together by drawing this dotted line. What you notice is by doing that, we just created an inscribed angle. So we have this angle B right here. One leg touches C, the other leg touches D. Do we have a measurement for arc DC? We do. That is 40 degrees. So arc DC is 40 degrees, and we have an inscribed angle that ends, so we go from D to B to C. So we have an inscribed angle that intercepts these 2 points. So if you go back up to the definitions, we remember that, well, I guess we didn't define that today, but we've defined inscribed angles. No, it's right here. It's right here. Circle 2 shows an inscribed angle. The inscribed angle is half the measurement of the arc that it intercepts. So arc DC is included in this inscribed angle DBC. So if the arc is 40, the inscribed angle is going to be half of 40. So 40 divided by 2, that means this angle right here is 20 degrees between B and this imaginary dotted line. Right now, it doesn't really help us a whole lot. It will, but you're probably thinking, what does that matter? So we got 20 degrees right here. Okay, we have another inscribed angle. Now we can go from B to D to E. So you see this angle BDE. This is an inscribed angle as well because D is on the edge of the circle. Does this inscribed angle intercept an arc that we know the measure of? The answer is yes. Arc BE is 120 degrees. So if arc BE is 120, the inscribed angle BDE is going to be half of 120. Half of 120 is 60. If you do 120 divided by 2, you get 60 degrees. Okay, that leaves us with, we have 20 degrees for B, 60 degrees for D. If you look carefully, when we drew this imaginary line, we formed a triangle. Triangles add up to equal, or the angles inside of a triangle add up to equal 180, which means we can find this little angle, G, right here. So this is 20, this is 60. What is this angle? Well, angle G is going to be 180, which is the total, minus 20, minus 60. 180 minus 20 minus 60 is equal to 100 degrees. So this is 100 degrees. We have a triangle that's got 100, 20, and 60. How do we get to X? Well, we know that this is a straight line going all the way across here. So straight lines equal 180 degrees themselves. So if this part is 100, this part, X, is going to be 180 minus 100 to get X is equal to 80 degrees. This is 180 minus 100 is equal to 80. And this is 180 because straight lines are 180.